Okay. Yes, I'm ready. Vinny, go ahead.
So it's just f of x equals 12 over x?
And we're asked to find the difference quotient?
Yes.
Okay, the difference quotient for you will be given. Not difficult to remember, but it doesn't matter. It will be given in this class. So it's f of x plus h minus f of x divided by h. Okay. Now, what we have is this, which is 12 over x. This, no one can do anything about. And the only thing that we don't have is this. But that's not a problem because I see the pattern, 12 over blah. Well, f of this then will be 12 over x plus h. And now I will put everything together and simplify. So I copy 12 over x plus h. Let me know if you can see. Divided by h. H, remember, is the same with h over 1. Okay, so now the next step. Obviously, we have to find the least. I'm sorry, I forgot to turn off my phone. Hello? Okay, let me turn it off now. It was a robocall, obviously. It's turned off now. Okay. Okay, one student emailed me that I didn't send the link, and that's true. I didn't send the link through an email. Just allow me one more second. So we have to find the least common denominator. Can anyone give us an idea about what is the least common denominator when we want to subtract these two fractions?
Would it be x times
yes.
x plus h?
Yes, because they have nothing in common. They are completely factored, and that's the only way. So x times x plus h. Obviously, we cannot just copy the numerators. What I would have preferred to do is put 12 in front, pull it out right here. And I'm going to do that. So I have 1 and 1. This needs to be multiplied by x, and this needs to be multiplied by x plus h. Exactly what it does not have in the denominator. 12 is completely out, so x times 1 will be x, but now negative 1 times x and negative 1 times h. Negative x, negative h. Now remember, two things have to happen when we determine or simplify, find and simplify the difference quotient. What are those two things that must happen? One, h from the numerator has to go away. Is that clear? Anything that does not have h. So eventually this h will go away, but everything that does not have h in the numerator has to go away, and it does. So now we have a 12 and minus h. Oops, that's not a good color, sorry. So negative 12h divided by the denominator and multiplied because I have to flip. So first step, remember, all terms without h must go away. Second step, h from the numerator has to go away somehow. Not this one. This one can stay. I'm talking about this one. This one will have to go away. And because of that, because this has to go away, all terms without h must go away initially. So then I have negative 12 divided by x times x plus h. And this is basically the rate of change of this function at any point, the instantaneous rate of change at any point, with some additions in there. But this is basically a function that gives us the rate of change as close as h approaches 0, but we don't do that in this class. So this is it. That's where we stop. So is this better?
Yes, thank you.
Very good. Next question. Anything you like? Anything? Okay. Let me just answer again, Tiana, that I did send it. Sorry, I just sent it. Okay. Any questions? Anything else? What is the next step? What are we doing? You can choose from problems from the previous test. You can choose problems from the book. You can choose problems from my math lab. You can choose problems from the previous final exam that I posted. Anything. Anything, anyone.
Yeah, I have another one. Can we go over
Yes, of course.
the piecewise?
Yes,
functions?
yes, any function, yes, please. Very good.
Let's do just some. I just want to see one where there's a greater than and a less than.
Yes. Anything you want.
I don't have anything off the top of my head. Sorry.
That's fine. We can choose from the book. You want me to choose from the book, or you want me to choose any other? Or
from the book. From the book is fine.
You want me to make one up, or?
Yes, please. Thank you.
Okay, sure. So let's say x squared minus 1 for x less than or equal to 0. And let's say 2 to the x for x greater than 0. Now we can be creative because we know so many functions. Good. Our first step must be the domain. So I will change this into negative infinity to 0. And I will change this into 0 to infinity. Obviously, the function is defined everywhere because this is defined everywhere, this is defined everywhere, and between negative infinity and 0, 0 is there, 0 to infinity. So everything is there. So nice, no problems here. So then I start a table between negative infinity, and this is f of x. Okay, and obviously I see that the potential problem is 0. So 0, it has a bracket to the left, and it has a parenthesis to the right. On this territory, I will be using x squared minus 1, and on this one, I will be using 2 to the x. Okay, so then I know how to graph this. When I graph x squared minus 1, we graphed it so many times. This is x squared, and this will be x squared minus 1. But I have to graph between negative infinity and 0, not this part, just this part. So I'm just going to plug in. I know that it's going to be 0 at 1, negative 1, of course. Negative 1 squared, which is positive 1 minus 1 is 0. And at 0 will be negative 1. Now on this side, when I plug in 0, this will be 1. 2 to 0 is 1. When I plug in 1, 2 to the first power is 2. That's basically all I need. So now let's graph the function. On the left-hand side, I have at negative 1 is 0, and at 0 is negative 1, and they are both solid points. I know how to graph. It's a quadratic function having a minimum. The leading coefficient is positive 1. It has a minimum. On the other side, at 0 is 1, but it's an open point because I was not even allowed to plug in 0 here. 0, 1 will be an open point because this one is a full point. And at 1, it's 2. I know how to graph 2 to the x. 2 to the x looks like this. But I cannot graph this part. I can only graph this part. So here's the graph. And this is the graph of f of x. And if we're asked to find the range, can anyone give us the range of this function?
Is that -1 to infinity?
Absolutely. I have to change my glasses. Yes, indeed, from -1 to infinity. From -1 all the way to infinity. Great job.
So when you are putting in values for x, are you just picking like anything?
No, it's a very good question. That's why I showed the graphs here. So I'm normally picking for the exponential, I can pick anything, really, but I don't want to pick 15, because if I pick 15, I'll have 2 to the 15th power, and it doesn't fit anywhere. It's so huge. For x squared minus 1, that's why I graphed it here. Because we know using transformations, this is x squared, this is x squared minus 1. So I know I have to find the x-intercept, and I know I have to find the y-intercept. Does it make sense?
Yes, thank you.
So I always look for the x and y intercepts. But e to the x doesn't, 2 to the x doesn't have an x-intercept. Nowhere, especially on 0 to infinity. Good. Very good questions. Thank you. Let's move on. Next problem. Anything? 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 Let me help you finish up your homework for test 3. Or choose problems from the previous test. Test 3. Anything, please. Let's not waste time. Anything you want.